Hi guys. We're going to be solving 3 variable systems algebraically for the next couple days. So we're going to be practicing some more linear programming, but we're also going to be solving 3 variable systems algebraically. When you have 3 variables, typically you're talking about an x, a y, and a z. So you have an x coordinate, a y, an x-plane, a y-plane, and that's usually 2D, but then imagine a pen sticking out right here in the center of this, sticking straight in there. That would be the z-plane. Okay, so you can imagine if I have 3 planes, there are many different ways that I can get solutions. The only way I can get one solution is this example right here, where all 3 planes intersect in that one point right there in the middle. Okay? An infinite solution, infinitely many solutions, is when they all 3 intersect in a line, all right here. Okay? No simultaneous solution can happen in 3 different ways. So they could be parallel. 2 could be parallel and 1 could be cutting through them, or they could arrange themselves in kind of a triangle formation. In all of these situations, I don't have a solution because there's nowhere that all 3 intersect. Also remind me that we need to go through inconsistent and consistent. Okay. All right. So there's a lot of math involved in solving a 3 variable system, but basically what you're doing is you're going from 3 variables to 2 variables, and then 2 variables to 1 variable. What you've done so far is go from 2 variables to 1 variable. So I'm going to first number these. So this is going to be 1, this is going to be 2, this is going to be 3. And that's kind of important to do just so that you can keep your math organized. So what I'm going to do is I'm going to take equation 1, and I'm going to take equation 2, and I'm going to multiply equation 2 by 2. Okay? So instead of writing it like that, I'm going to say multiply by 2. So equation 1 is staying the same. 3x plus 2y plus 4z equals 11. Now I'm going to multiply the second equation by 2. So 4x minus 2y plus 6z equals 8. And if you can see, I've eliminated the y. I'm going to add these. Okay, now I'm going to take equation 2, and I'm going to multiply that by negative 3, and I'm going to take equation 3. So if I multiply equation 2 by negative 3, I get negative 6x plus 3y minus 9z equals negative 12, and 5x minus 3y plus 5z equals negative 1. So I kept 3 the same, and you can say I also eliminate the y's here. And I'm now going to call these A and B. Let's go over that. A and B. So I'm going to take A and B over here, and I'm going to write them. And negative x minus 4z equals negative 13. And I'm now going to solve this system. So I'm going to multiply b by 7. So a and b times 7. So a is going to stay the same, and b is going to become minus 7x minus 28z equals negative 91. The x cancels. I get negative 18z equals negative 72, and z equals 4. So remember, I will have an x, a y, and a z coordinate. I have a 4 for the z. Now I can take that, and I'm going to take this 4 and I'm going to substitute it right in there. So I'm going to substitute that z in for that z. And I get negative x minus 4 times 4 equals negative 13. I'm going to add 16 to both sides, and I get negative x equals 3. So x equals negative 3. I now have the x. I'm now going to take the x and the z, and I'm going to plug it back into one of my originals, and I am going to plug it into the second one. So 2 times my x minus y plus 3 times my z has to give me 4. These two combined give me 6, so I'm going to subtract 6. So y is going to be 2. I now have my y, and I have solved this by elimination. Okay, so in this situation here, I'm going to multiply the top equation by negative 4. So I'm going to take 1 and multiply it by negative 4, and I'm going to keep 2. So I have negative 4x minus 4y minus 4z equals negative 12, and I think you can see what's going to happen. Cancel, 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 so I have 0 equals negative 5. No solution. So I'd like you to pause and try this one. I believe if you take 1 and 2 and 2 and 3, you can automatically cancel out the z's. There's your beginning. Pause, please, and work through it. So if I just add 1 and 2 together, I get this. If I add 2 and 3 together, I get this. I'm now going to multiply this equation by negative 2. This is my A. This is my B. This will give you an IMS solution, infinitely many solutions. Okay, let's look at a substitution. Since r is by itself, I'm going to plug r into both of the other equations. So I'm going to plug it into 1. And my new one is 100 and 200t, 200 and 500n equals 30,000. And my second equation, my number 2, becomes 2t plus 2n equals 60. Now I've brought it down from 3 variables, t, r, and n, to 2 variables, t and n. And I'm now going to multiply this bottom equation by negative 150. So that will give me negative 300t minus 300n equals negative 9,000, and the top equation stays the same. So I have positive 300t, positive 700n, positive 30,000. I'll end up with 400n equals 21,000. I will get n equals 52.5. And I can now take that and plug it into, either of these and solve for t. And if you do that, you'll get t is 30. Nope, T is negative 22.5. And then you plug both of these in and you'll get R is 30. So T, R, N. T, R, N. Okay, and we will be practicing this tomorrow, so come ready to be able to do these. If you need to go back and replay this, then you need to go back and replay it and make sure that you understand what's going on, or at least understand enough to ask questions. I'll see you tomorrow.